All right, looks like we're up and running. I'm going to introduce quite a bit of new material here in the next few days. We'll do look at three things for today's class. And of course, you're looking at this over the weekend. Today's class is actually next Monday. So maybe I should have described it a little differently. But here we have look at some triangular relationships. We've done a lot of work with Pythagoras this semester, so finding the three sides of a right triangle should not be a problem for anyone in the room. And so if we have an angle and a 90-degree triangle here, then next to the angle, the width here is called the adjacent side, opposite, right? Opposite the angle, and the hypotenuse is the longest side in the triangle. We've already talked about that. And so just like logarithms, day one, I wrote out this long sentence and said, we cannot communicate that way mathematically. It takes too long to write this. All right, but this is what I want you to do. I want you to compare, and we'll use this triangle right here, drawn in standard position. Origin right here. We're going to develop a concept, obviously. And this is the first thing to consider. So I want you to compare the length of the side opposite the angle to the length of the hypotenuse. So you can pause the video, put a little period at the end there. Pause the video and see if you can answer that question. Can you compare the length of the side opposite the angle A to the length of the hypotenuse? I'll just keep talking and I'll assume you've pushed the space bar and come back on. Well, needless to say, we got to find that length, right? And I don't think I have to do this, but 3 squared 9, 4 squared 16 equals 25. And so there's the square root, which is 5. So I hope that's not a problem. So can I compare the angle, the side length opposite the angle? Opposite the angle is that one. So can I take that 4? And can I compare it to the length of the hypotenuse, 5? I think that's a comparison. I think I answered the question. Now, is there a different way to frame that question? Yeah. Let me get an eraser here. Obviously there is, or we're going to have trouble working with this calculation. So if I wanted to, there goes the knee. If I wanted to ask you to do this, I wouldn't have written that. I would have written this. The sine of angle A. And I would have hoped that you would have answered it 4/5. Now, if I change the side opposite to the adjacent side, it's a new question. Yeah, I guess I'm making A out of that. Adjacent. Okay, and side. All right, well, the adjacent side is the width here, 3 to 5. And obviously, if I'm answering that, then I can't use that command. I have to have a different command, and you may have already anticipated it. That's the cosine of angle A. We might as well cut right to the chase. So what's the tangent of angle A? There's a lot to do with slope tangents. Oh, rise over run, 4/3. All right, so I'll give you a different picture here. And I could draw it in any quadrant. I could work in any quadrant. In fact, I think I will. Because we want to get negative numbers involved. So why don't we go over here? Let's do -2. And let's do, how about -5? And let's see if we can answer these three questions. Now, A, this is 0 degrees over here, right? And as I go up to 90, all right, I'm really going over to 180 and 270. So we call this the reference angle. Okay, so let's call that the reference angle. And let's take a guess at what A might be. A might be, 100 and, to get here, closer to 270, I think. I wasn't anticipating saying this, but a little more than 45, so maybe it's around 230, 240. Where if you were thinking about this as a circle. I don't think I'm going to do this right now. I put a little seed, planted a little seed. Let's get back to the first quadrant. I got off on a little tangent here. So let's look at this one here. Let's keep that angle A. It's between 0 and 90 degrees. Maybe we'll even find it in a moment. All right, so let me give some numbers here that make some sense. How about 5? And if that's 5, this is 11. All right, and you answer these questions. Hit the space bar and you go ahead and do them. I'll just keep talking. So we got ourselves 121 and 25. 121 and 25. My brain's tired, so I'll look at it. 146. All right, so this is the square root of 146. And the square root of 144, by the way, is 12. So that's a little bit bigger than 12, and it's certainly the longest side. So what's the sine of angle A? 11 over the square root of 146. What's the cosine of angle A? 5 over the square root of 146. And what's the tangent of angle A? 11 over 5. Now, if you want to find out what that 3, 4, 5 triangle was, let's go back to that. The numbers are smaller. And if we wanted to find the angle, let's say that's 3, that's 4, that's 5. 3, 4, 5. And I want to know what angle A is. Well, let's go back to naming these 3 again for a little practice. Sine of angle A, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And people who don't memorize these right away end up in trouble. Tangent, opposite over adjacent. Rise over run. Okay, so if I wanted to find out what angle A is, I could type in the whatever bar, the Google, you know, that thing Google. All I'd have to do is look at this and say, well, this is angle to ratio. That's the order we're doing things in. Well, if I gave you the ratio, we'd have to reverse the order. So I hope this makes some sense. Sine -1, right? We have f of x, the sine function, and we have its inverse. This function works with an angle to produce a ratio. Therefore, this has a ratio to produce an angle. So you'd have to type this in. What was it? 4/5? So you have to do the arc sine or the sine inverse of 4/5. And probably should write after it. So this is what you do. You type sin caret stick -1 and type 4/5 in parentheses and write in degrees. Because there's 2 language systems and what we're just beginning to look at. So caret stick -1 is the way you communicate. And then, you know, 4/5. And you can guess what that angle is before you put it in there. What do you think? It's more than 45 degrees, right? This side's more than that one. So I don't know what it is. I'm going to guess 58 degrees. You go find out. That's my guess looking at the picture. Do I really know? No, I don't. But I'd go with 58 degrees. So go ahead, type this into Google right here and write in degrees and see if you get anything close to 58. And let me know. All right, so that's what we're going to practice on Monday. We're going to draw triangles in standard position. I will do one that's got some negatives because I'm sure we're going to probably get to that. So let me clean this up. Do a little drawing here. Get rid of those ratios. Let's say that x is -2 and y is 3. You find sine, cosine, and tangent. And I'll draw the picture. So this is our reference angle. Okay, and that's our true angle, 0 degrees to, oh, looks again to be probably around 130 degrees, maybe, I'm guessing. All right, so you go ahead and push the space bar there, take some time, and I'll just do this problem. So that's 4 plus 9, which is 13. So that's the square root of 13. which is a little more than 3. It better be because it's the biggest side. And so I'm looking at the sine of angle A, which is 3 over root 13. I'm looking at the cosine of angle A, which is minus 2 over root 13. And I'm looking at 3 over negative 2, but I know no one in this room would leave it like that. Everyone would move the negative into the numerator to show that you have been receiving some instruction. And so that's how we're starting. Just defining sine, cosine, and tangent. And I suppose the inverse sine, taking a ratio and going back to what angle produced it. I don't want to talk too long here. I just want to lay out just a little bit of get us started, plant a seed. So we've been looking at functions. And eventually we're going to get to being able to write these equations just as quickly as we write the equation of a line. I mean, most of you have in the last week or two begun to look at the graphs, which is nice. I suggest that you look at this material a little bit more often in a consistent basis, so you don't have to wait till the last 2 weeks to see major changes in your scores. There's a little old man lecture, all right? But we have been looking at, functions with a little multiplication and a constant for the most part. And whether you realize it or not, we've been breaking it down to putting an x in and making that part of the function equal 0 and 1. Because if we make it 0, then we multiply and add a constant, then that first x gets us c. And if we make the function equal 1, and we multiply and we add a c, then that second one gets us m plus c. I mean, we can really see it in the exponential, right? The exponential starts with the height of 11 there, right? And then we have 3 as a unit, and then 10 times 3, 30. And that comes from putting 1900 in, working with a 0, getting a 1. I mean, it's the kind of model we're setting. We're going to do the same thing here. We're going to be able to write that for those of you who put the time and effort in. 2-3 weeks from now, you'll write that equation in probably under 10 seconds. It's going to take a little practice to get there. All right. And so I just want to encourage you to put the effort in, thinking about it on a daily basis. You don't have to learn it in one day. Take 4 or 5 days, but think about it 4 or 5 minutes a day for 4 or 5 days. And I think you'll make some real good gains. So we have to talk about something called radians in order to get an understanding of this. And radians is another language for measuring angles. And I don't think I'm going to talk any more about it right now. I think just for our purposes, drawing a triangle in standard position and getting the definition, sine, cosine, and tangent, it's enough because we got 2 other videos to watch. All right, and so we'll get started and then we'll do a little lecture to take us further along as to how we're going to deal with that. All right, that's enough said.